I, Mrs. K. S. Gadgil, Department of Electrical Engineering, AISSMS IOIT Pune, is going to talk about Introduction to Active Filters. Let us first understand what a filter circuit is. Filters are circuits that are capable of passing signals within the band of frequencies while rejecting or blocking signals of frequencies outside this band. This properties of filters is also called frequency selectivity. Filters may be classified in number of ways: analog or digital, passive or active, audio or radio frequency. What do you understand by analog filters? These filters are designed to process analog signals, whereas digital filters process analog signals using digital techniques. Passive filters use passive elements like resistors, capacitors, and inductors, whereas active filters employ transistors or op amps in addition to resistors and capacitors. The type of element also dictates the operating frequencies. For example, RC filters are commonly used for audio or low frequency operations, whereas LC or crystal filters are employed at RF or high frequencies. The analog or digital filters can be subdivided into five categories: low pass filters, high pass filters, band reject filters, band pass filters, and all pass filters. Let us see the frequency response of each of these filters. We start with low pass filter. The figure shows the frequency response of a low pass filter. The ideal response of the filter is shown by the dashed line. Just see this? Whereas the practical response is shown by the solid line over here. What do you understand by this? So, in case of low pass filters, all the signals of frequencies from 0 Hz to FH, that is the higher cutoff frequencies, have the gain as 1 or the same gain. Whereas after FH, that is the higher cutoff frequency, as the frequency of the signals increases, the gain of the signal goes on decreasing. The gain of the circuit, not the signal, the gain of the circuit goes on decreasing, right? The bandwidth of this is called as what? FH, right? At the frequency of FH, the gain is 3 dB down, right? So all the signals of frequencies which are from 0 to FH, it is called as the high cutoff frequency, pass through the filter circuit. That is why it is called as what? Pass band. Whereas all the signals which are greater than FH do not pass, and that becomes the stop band, right? Then similarly you have the frequency response of a high pass filter, right? You have the frequency response of the high pass filter. If you see over here, right from 0 to FL, that is called as what? The lower cutoff frequency, right? It is the stop band. Whereas at frequency FL or greater than FL, it is the pass band, right? It is called as what? It is called as the pass band, right? So from you will see from 0 to FL, the gain is not as expected, and then after FL, you have a constant gain, right? Then the next type of the filter circuit is the pass band filter, right? It is called as what? The pass band filter. If you look at this pass band filter or a band pass filter, what you observe is that it has two cutoff frequencies. One is the FL, which is the lower cutoff frequency, and the other is the FH, which is the higher cutoff frequencies. So all the signals, right? All the signals which are between the frequency from FL to FH, pass through this filter, whereas all the frequencies which are less than FL and greater than FH do not pass through this filter. That is why it is called as the stop band, right? If you check over here, the gain is 0 for the ideal filter, then it is the gain is as we want in the pass band, and again after fh the gain is becoming what? 0. So all the bandwidth of this filter becomes equal to what? Fh minus Fl, right? The bandwidth of this filter becomes equal to what? Fh minus Fl. So all the frequencies in this signals frequencies are going to pass through this band. Any other frequency which is less than Fl and greater than Fh is rejected or it is stopped. Similarly, you have what? Stop band filter, or you have band reject filter. It is also called as band elimination filter. What is the difference between the two? All the frequencies below FL and all the frequencies above FH pass through the filter, right? So you have a stop band or rejection band which is in the range from what? FH minus FL, right? So all the signals with frequencies in this band do not pass through this filter. That is why it is called as what? Band reject, or it is also called as band stop, or it is also called as what? Band elimination filter, right? Then you in between, if you see both these filters, pass band filter or stop band filter, you have what? You have a fc written over there, which is called as what? Which is called as the center frequency, which is it is approximately in the center of what? It is in the center of this stop band or the pass band. That is why it is called as what? It is called as the center frequency. This is the stop band and this is the pass band, sorry, right? Then you have the last type of filter, which is the all pass filter. We have not shown a frequency response of the filter, but we have shown a phase shift between the input and output voltages of an all pass filter over here. So this represents the input voltage, this represents the output voltage, and you have represented it with respect to time. Then what do you understand by this all pass filter? The filter passes all the frequencies equally well. That is, the output and the input voltages are equal in amplitude at all frequencies. So it passes all the frequencies well. The output and the input are equally well for all frequencies. With the phase shift, right? You can see the phase shift between the two. You can see the phase shift as pi between the two, which is a function of frequency. The highest frequency up to which the input and the output amplitudes remain equal depend upon the unity gain bandwidth of the op-amp. So it depends upon the unity gain bandwidth of the op-amp up to the highest frequency up to which the amplitudes of both the input and output remain the same. At this frequency, the phase shift between the input and the output is the maximum. So here we draw a plot of voltage versus time for input and output, and all pass filter means what? It passes all the frequencies equally well. That is, the input and the output voltages are equal in amplitude for all frequencies, right? So this was about the introduction of filters which are there. You have the low pass filter, you have the high pass filter, you have pass band, you have stop band or band reject. It is also called as band elimination filter. And the last one was the all pass filter, right? What are the applications of filter? These are extensively used in field of communication and signal processing. Radio, television, telephone, radar, space satellites, biomedical equipments are a few systems that employ active filters. So with this, we come to the end of the introduction of active filters. So we have seen the frequency response of low pass. Low pass filter means all the frequencies up to a certain higher cutoff frequencies will pass and then it will stop. Then high pass filter means all the frequencies up to a certain low cutoff frequency are stopped, and after that all the frequencies can pass through the filter. You have pass band filter where you have the bandwidth between FH minus FL, where FH is your higher cutoff frequency and FL is your low cutoff frequency. All the signals in this frequency range pass through the filter. Then you have the stop band where all the frequencies below the lower cutoff frequency and all the signals below the above the higher cutoff frequency pass through a circuit, and a certain amount of frequencies are stopped. And you have all pass filters where all the signals are equally passed and the input and output are equal in magnitude. And you have seen the plot of voltages, and it is a function of the they have a phase shift of angle phi, which is a function of frequency. Um, with this, we come to the end of the introduction of filter circuits. Thank you.